Before today's speech, let me tell you about a little bit about our company's background. Established in 1985, CYBERNET Systems has been providing CAE solutions and IT solutions through product sales, contract analysis, consulting, and software development for over 30 years now. We have developed a partnership with more than 20 companies, mainly in the United States, including ANSYS, Synopsys, and many others. Our head office is in Tokyo, and our CEO is Reiko Yasui-san. The sales subsidiaries of CYBERNET System consist of CYBERNET China, CYBERNET Taiwan, CYPHONE, which is based in Korea, and of course, CYBERNET Malaysia, which is based in Kuala Lumpur, and has been around for more than 1 year now. Up until this day, CYBERNET has been creating a network all around the globe. CYBERNET is working with overseas group companies to develop software that will serve customers not only in Japan, but also around the world, and also to develop our group products and solutions overseas. Next, CYBERNET Systems Malaysia was established in November 2018 as the first subsidiary in Asia after China, Taiwan, and Korea. Our managing director here in Malaysia is Hirokazu Tsuneki-san. Here in CYBERNET Systems Malaysia, we currently have 5 employees, which consist of management, administration, sales, and also technical departments. Our business here is mainly about CAE solutions, IoT, big data solutions, and also professional services. As you all know, CYBERNET Systems provides all sorts of solutions that can fit most of the customer's needs. Those solutions are CAE solutions, AR/VR, big data solutions, IoT, digital twins, AI services, IT solutions, and last, engineer services. So that's all about our company's introduction. And let's welcome our speaker, Will, to give us a speech about high-speed signal on PCB and analysis solutions.
Hello, everyone. My name is Will. I'm from CYBERNET. I'm a high-frequency application engineer. Nowadays, technological development and manufacturing breakthrough have made electronic products faster, smaller, and way more functional. Right now, 5G development has become very hot around the world. It also makes my topic today valuable and definitely worth your time. The topic of my speech today will be focusing on ANSYS high-speed signal on PCB and analysis solution. This is my agenda for today. CYBERNET. How do we start from scratch and then strip to nowadays worldwide business coverage? And I will show you how multifunctional and powerful ANSYS is. Also, I will be giving you some real-life thermal issues. You will meet for examples and provide some solution for them. Last but not least, our SIwave and HFSS demonstration. It will be our core part today. Make sure you turn into it. And we will have our Q&A time if you guys have any question for me. So this is my agenda. Okay. Introduction. I will introduce who's CYBERNET, breadth of technologies, high-speed PCB electronics, and thermal issue. Bring out the important things with ANSYS. So last, I show the multi-phases. Yeah. Okay. When we think about simulation analysis, we have to talk about CYBERNET, okay, which is the biggest CAE agent in Japan in this 20 years so far. There are a lot of fully developed solutions in simulation analysis. In Asia, not only in Japan, Korea, Taiwan, China, but also in Malaysia. The products and the problems we deal with will become the most powerful database. Okay. And in this multi-phases analysis, the first solution upon mind will be ANSYS, which also is an angel product of CYBERNET. ANSYS is the most public content software in the world. We have a lot of covering samples, not only in materials, current, mechanical, but also electronics database. It helps users have excellent experience in product development to design a most competitive product. So you can see ANSYS is a very software to solve the technologies things. Okay. Okay. The graph on the left-hand side is the thermal issue. So you can look at this. This trace is hot and become to black color. Yeah. This picture is thermal issue that what occur when signal transmit on high-speed PCB. Yeah. With the faster transmission speed of signal, the greater electromagnetic field will be worn out and decay. In the meanwhile, the thermal issue will happen. Yeah. This issue is will be really difficult it's difficult to improve via experiment. This is where the ANSYS software jump in. Okay. Therefore, the electric thermal coupling problem has become a crucial topic today. So you can see use SIwave aspect to link to do couple. You can see the this picture can see the temperature distribution or and the electric potential control on a high current trace in a PCB. Yeah. ANSYS provide the multi-phase solution. Because it has many customers and one of the big database on the world. ANSYS will improve many options and the solver to solve users situation. Yeah. Now, multi-phase solution will take a lot of application. Is example the cell phone, the car, the many applications. Yeah. So simulating interaction between among different disciplines, different kinds of phases is increasing important, and ANSYS addresses this in many ways. In EM field, HFSS and SIwave provide the electromagnetic field. SIwave linked to the ANSYS software portfolio for multi-phase simulation of electronics components. One option is to export a power distribution map from SIwave into ANSYS aspect. This multi-phase solution enables accurate thermal modeling of IC package and PCBs using DC power loss from SIwave as a heat source. Yes. Aspect solve the challenges associated with this dissipation of thermal energy from electronic components that may cause premature component failure due to overheating. Yeah. You can then evaluate thermal stress with ANSYS mechanical. This multi-phase approach enables you to perform coupled EM thermal stress analysis for a complete understanding of the design prior to manufacturing. So you can see this picture. You can use EM field to thermal to stress do the two-way couple. Okay, this graph is the coupling result. This is a coupling with aspect and SIwave two-way couple. Yeah. We all know on the PCB the loss of the trace. We can use airdrop in SIwave to simulate it. And maybe you will ask me what is IR drop. I will talk about this later. Yeah. From the decision of the voltage drop, we can get a load source. Link the loads in aspect. We can get the result of the thermal distribution and temperature. Okay, SIwave will analyze the S parameter and SIPI according to the thermal distribution. We will know the temperature would affect the material feature and the health of the trace. See, so I hope the simulation result to improve the temperature thermal issue. Yeah. Okay. So we know current crowding in a trace plan vias lead to high Joule heating loads in the PCB. And the layer by layer Joule heating power max from SIwave are transferred into aspect. So you know you can layer by layer. So you can clear to analyze the power map and the overheating. Yeah. So ANSYS software will link SIwave power map to aspect is so friendly. Yeah. First of all, the traditional PCB manufacturing process contains providing design ideas of layout and the EMI for concerned personnel and mechanical structure design for agency. In addition, concerned personnel will make a pass or fail evaluation with tester after splitting production. Yeah. If necessary to design and produce from scratch, if the result fail the test, yeah. So your test is so failed, you must begin to idea and recycle. Yeah. So the cycle costs quite amount of money and time. However, the appearance of ANSYS simulation software changed the circumstances. The software is able to evaluate whether PCB layout is excellent and retrieve results from the software before the final testing. And leading to all design product operating better performance. Moreover, importing simulation software is not only budget friendly and time saving, but also manages to evaluate the weakest circumstances with advanced notice. So this conclusion for now is that I think one cost and the time reduction to produce a number of multi-properties for each new project. Cost to assembly measurement cost. Yeah, and time loss for designer in waiting for properties. And to decrease serialization of PCB prototype, a reduced delay in the overall process. Now, three, improve quality by simply testing. You can never be sure that the solution is the best one possible. Yeah. Okay. Okay. So now I will introduce SIwave, and SIwave bring out the benefits of PCB simulation. First of all, let's start with cable and connector simulation. And this is a high-speed system. Yeah, so you can see the BGA and the ball and the connector and the cable and the yeah. So we use HFSS in this 3D module to simulate the transmission characteristics and the influence of EMI. Yeah, because HFSS is a 3D FEM software, it can get a 3D field. So you know the connector and the cable is the 3D model. So using HFSS software is very is a good choice. Yeah. With HFSS simulation, we will now if the product characteristic need to improve, so we can use HFSS to improve the result. Yeah. It not only can get a field and a trace, but also the antenna radiation field and the antenna effectiveness. So in numerical analysis has a lot of ways to get the answer faster and to make the result more specific. Second, the ball and the BGA with SIwave, we can simulate the ball of trace to get the best choice. We can calculate the surface current and the change of impedance with MOM wave. So you can the S parameter TDR I diagram and the I diagram of SI and the R drop PDN SSN of PI also can become visible in SIwave. So you can see the PCBs. You can use SIwave to simulate. How to analyze system of electronics products? You can simulate it completely with ANSYS. Okay, so for the next part, I will be focusing on SIwave. Okay, so you can see the this graph. You can see the SI is signal integrity. So you can see the diagram, and you can see the left picture is power integrated. This is a impedance. Okay, and I think this picture is an EMI because when the connectors the trace to trace is very gap is very small, so your couple is very strong. Yeah. So EMI we need to simulate and improve it. Okay. Okay. ANSYS SIwave is a specialized design platform for power integrated, signal integrity, and EMI analysis of IC packages and PCBs. SIwave help you model, simulate, and validate high-speed channel and complete power delivery systems typical in module high-performance electronics. Yeah. So when your customer has the layout file, you can input to SIwave to simulate SI and PI result. Yeah. It accurately extracts multi-gigabyte SerDes and memory bus, providing product size of compliance for various designs. SIwave's full-wave iteration of complete power distribution networks, I think is PDN. Yeah. Is power distribution network. This is PI is very important analysis one. Okay, enable you to verify noise markings and ensure impedance profiles and master automatic decoupling analysis in low voltage design. A successful design of a next generation electronic product requires power integrity, signal integrity, and thermal integrity co-analysis. So, previous I told about the SIwave and the aspect to couple. Yeah. SIwave uniquely handles the complete of interconnect design from side to side across ICs, packages, connectors, and both PCB by leveraging advanced electromagnetic, thermal, and mechanical simulator dynamically linked to powerful circuit and system simulation. You can understand the performance of high-speed electronic products long before building a prototype in hardware. This approach enables electronics companies to achieve a competitive advantage with faster time to market, reduce cost, and improve system performance. And so I will introduce the solver in SIwave and the ANSYS perform. SIwave enables a streamlined ECAD design flow for 3D electronic Uh, uh, okay. I think SIMP power signal integrity and power integrity and DCI drop. The DCI solver specializes in predicting DC power delivery issues within electronic package and PCBs. The solver uses a unique adaptive mesh refinement algorithm to ensure highly accurate modeling of ECAD primitives such as planes, trays, vias, bond wires, solder bolts, and solder bonds. The DC solver also allowed bidirectional coupling with ANSYS SIwave to account for thermal effects due to Joule heating. So I think it's very important. So yeah. And the ANSYS solver, the ANSYS SIwave ANSYS solver computes a resonant mode SYZ parameters and the frequency domain voltages. It also predicts near and far field radiate emissions, incorporating sophisticated domain decomposition technique. The LC solver is well suited for modeling non-ideal structure in the largest, most complex design. Such structures include, but are not limited to, tracks route across split, poly reference tracks, and the vias content within irregular antipaths. The ANSYS solver also incorporates repeat full design signal net scan capability, allowing SI engineer to quickly identify trace impedance and time frequency domain, time or frequency domain crosstalk variations. And the PSI 3D fast FEM solver is used for extracting PDN as parameter or SPICE models from IC package and PCBs, similar as HFSS solver. Yeah. In addition, a 3D AC current can be visualized in SIwave, showing signal power and return currents. And the CPA, the chip package analysis solver, is used for extracting RGC analysis for large chip package design. IC designer leverage the CPA solver within ANSYS Redhook for visualization of chip and package design. HFSS and the PSpice. The HFSS circuit solver can be used from the SIwave desktop when time domain SPICE analysis is required for timing analysis. So we can use the other software is designer in ANSYS. Yeah. Okay. So what is signal and power integrity? High-speed signals make the application of SIPI more important. So SIPI determines if a signal transmits from point, maybe this is point A as a larger level 1 or B received correctly at point B as a larger level 1. Poor SI and the PI design create electronic noise that can become EMI. Proper placement of decoupling capacitor and routine of signals remove this noise. So you can see the impedance is not the same. So the loss is very strong. Yeah. So we need to solve the SI and the PI. Yeah. So then you can see this graph. Yeah. Typing a signal pass from one end of the channel to another can be represented by this slide. Typically, we have theta and TX and I transistor, a level-based model. The channel in between is represented by the numerous passive element. Has a SMA connector, PCBs, and different type of routine vias. Each of these transitions and different types of passive models will introduce new discontinuity in signal path. And this will result in signal distorting, which will reduce overall bandwidth of the system. So the eye that was open at the input channel will eventually be closed by the time it reaches the channel end. So in this stress, we need the signal integrated and many result example S parameter and TDI and the I diagram is very important. Yeah. So so we care this TDR time domain resistance and I diagram and S parameter including return loss and insertion loss. Yeah. Okay. So we need to know PCB design. In here we have to provide two solutions. The power integrity optimization and first, there's no PCB geometry. No capacitor has been placed on PCB. So PI engineer is tagged with you meet PDN impedance profile specified by IC manufacturer. So solution is capacitor library bronze. So I will show the capacitor value in later. Yeah. And the second, real board design. So basically, functional design with all decoupling capacitor already placed on PCB. So a PI engineer may want to increase capacitor count in order to make design more robust, reduce the capacitor count, reduce number of different capacitor type used, and redesign using lower cost capacitor, because I think you use many capacitor your cost is higher. Yeah. So the solution is PI advisor. Yeah. So solution PI advisor is so step one, select a port location to optimize and the impedance profile to meet. And step two, select a capacitor to optimize. And last, select a loadable candidate for each capacitor selected for optimization from accelerometer or circuit library. So and you can launch PI advisor. So you can get a two grapher. Yes, the first one is over design, because you use the total 36 capacitor. Yeah, so it's over design, and so I improve the design. I use total is 11 capacitor. So at least result is I think is the best in this design. Okay, so we also care PI because a DC IR drop and the PDN and are very important points. And so currently we simulate and improve power situation using SIwave. So SIwave is powerful software because he can solve the SI and the PI. Yeah. The PCB via is more and more important in the high-speed signal. So we can use HFSS, which is 3D environment, to simulate 2.5 dimension problems. It would make the SIwave more accurate because we think HFSS is 3D environment, so simulate the result is correcter than SIwave, but with the HFSS region function, we select the area of the 3D solver in SIwave. So you can in HFSS you can set the region. It can simulate independent with HFSS solver. ANSYS is really mature in mixed solution. So I think in high-speed signal we need I think no one could rival him in this respect for sure. So you can in the same project you can set the many region. You can see this and has region 0 to 3. So it's many via, and you can use HFSS region and solver to simulate. Okay. What do I say the importance for SIPI on high-speed board? I will show some example to you. Okay. So this is package SI ANSYS benchmark. This slide show a close-up view of critical differential pair that will be analyzed. So you can see this graph. This is differential pair. Yeah. SIwave being a full-wave frequency domain package extractor were used to extract the passive behavior of this package layout. Nothing will be used as a circuit simulator to get TNS and far field and near field behavior of this model and compare it. In the VS measure data. Okay. So you can see this graph is a package SI result. Okay, so you can see overlay of far and noise simulation to measure data. You will see the simulation result as similar as measurement. ANSYS will be a golden software. So many famous company decide to choose ANSYS. So okay. So you can see the solid, the color, the line is solid is simulation, dash is measurement. You can see this is very similar. Okay. This is the last example. So this is PCB channel Gen 3. So this system of a design has a package, socket, PCB board, and connector, cable, and maybe I think IC's IBIS model. Yeah. So you can see this design in designer in ANSYS. So you need to simulate I diagram. So you can see this theta, TS and IS. This is I source and I probe. You can see the I diagram. Okay. So a channel in designer showing all the different components. Each component represent an array of models. Example show is the circuit component. This array contains 12 different circuit models. Yeah. So this is less PPT. Thanks everyone. Yeah. So you have any question you can ask me. Thank you.